factorization. Have you heard of primes before?
Yeah.
Yes, sir.
Good. So when I define what a prime number is, everybody already knows.
Yes, sir.
What is a prime number since we're so smart?
Anything that doesn't
You got the right idea, you just don't know how to say it.
multiply by another number.
Oh. You're on the right track, but you're kind of lost. What do you think, Holden?
Can't be divided by anything other than 1 in itself.
There we go. Except we're going to write it a little better than that, too. Which is what she was trying to say, but she was all messed up. But okay, prime number. Any number that can only be divided. What a dingo. Divided. But we say divided. It's divided, isn't it? Okay. Can only be divided by itself and 1. A prime number is any number that can only be divided by itself and 1. So, let's start a list of them.
2, 5.
No, we got to start.
1,
before
3,
that.
5, 7.
1 is not 1. 1 has one number that will divide into it.
3.
Itself only. So the next one would be?
3.
Nope.
2.
2.
3.
3.
5.
5.
7.
7.
9.
No.
11.
11. 11.
11.
11, yeah.
13.
13.
15.
No.
17.
17.
20.
19.
23.
23. Don't say 21. 21 can be made by a 7 and a 3 and a 21 and a 1.
29.
27.
Thank you very much. 27? I don't believe so.
29.
9 times 3 is 27. 29.
31.
31.
30.
33.
Nope. 33. 11 and 3.
37.
37.
41.
41.
39.
13 and 3.
10 and 3.
40. 3. 2. 47. 1.
41.
Oh, I forgot.
43.
43.
47.
47.
51. 49. 52.
51.
No.
53.
51 will divide by 3 17 times. What are you looking at, dude? How do you know 53 is?
Because there's no dots on it.
There's no dots. Oh, we're figuring something out, aren't we?
59.
59.
61.
Ah, now you're smelling the
67.
cheese.
67.
Yeah, that's a nice list up there, isn't it? If it doesn't have a green or a red or a blue dot.
137.
So, I'm stopping right here because there's a whole lot of them, right? But you get the idea. Correct? Yeah, you should have because you wasted a lot of space. But that's okay. You can still turn the page. Okay. Now, that takes care of our word prime in our factorization, prime factorization. We know what prime is. Our answers will be prime numbers because we're looking for prime numbers. If your answer has a 10 in it, then it's wrong today because 10 is not prime. Is everybody with me? If your answer has a 6 in it, it's going to be wrong because it's not prime. Now we're talking about our base numbers, okay? Our base numbers. All right, so we're looking for prime numbers. Now did you notice the only even number that's prime is the number 2. So I'm going to write up here just a little star. Only even number prime repeat that. 0 and 1 are not prime. 0 and 1 are not prime. Okay?
They like you.
Okay? Okay? All right. Now, if the number's not prime, it's called composite. Composite, yes. Composite. Any number that has more than 2 numbers that will divide into it. Okay? And now I'm going to add something here. 0 and 1 are not prime, right? But I want you to think on yourself, I'm not going to write nothing, are they composite? And just think about that for a couple of days, okay? And we'll discuss it another day. Okay? Think about it. Okay. Now, there's a word up there in the big word that we need to talk about. What's the word in the big word?
Factor.
A factor. No, not isation. Just the word factor. Just the word factor. It's a fancy word. It's a fancy word for the numbers you need to zoom in a little more with that plus sign, dude. Yeah, and come down here where I'm writing. There you go. Fancy word for the numbers that will divide into other numbers. So in other words, right here on our definition of composite, any number that has more than 2, we could have, instead of writing all these extra words right here, we could have said more than 2 factors. This fancy word factors takes the place of all that other stuff about something dividing into something else. It's just a fancy word. All right, Kiana, is that okay? Factors. Number that will divide. Okay. So, prime factorization. Prime factorization. Prime factorization is the process of, and I hate putting this on film. Sit down, Holmes.
Elimination.
I hate putting this on film because everybody yells at me, but I'm going to put it on there anyway. They can fire me. It's all right. Prime factorization is the process of, I call it busting. Busting up composite numbers into nothing but prime factors, prime numbers that will divide into them. Prime factors. And we just defined factors as a fancy word for the numbers that will divide into something. So it's a process of busting up composite numbers into nothing but prime numbers that will divide into it. Toye? Toye. And there's two ways or methods to do this. You may have already done these in the 5th grade in elementary, and that would be awesome if you have. But we're going to do it again. One of them's called the factor tree. How many of y'all have heard that before? Looky there, y'all have looked at it. The other one's called stair method. I'm going to do them both. You choose the one you like. I will not force you to do one when you don't like it. Now, you can't choose to not like either one of them, though. You got to pick one of them. All right, nice try there, brother Sam. I know Sam's going, I'm not going to like either one, so I'm not going to do it. No, I'm not doing that, Sam. You got to pick one of them. Is that a deal? All right. I'm going to do 36. Is 36 a composite number or a prime number?
Composite.
Composite. Things will divide out of it, won't it? And so we make a Christmas tree. If 36 will bust down, as I call it, or something will divide out of it or make it, then you get two branches off of it. Now, what times what, Ty Watson, equals 36?
6 times 6.
6 times 6. Do we agree with Ty Watson?
Yes.
Yes, we do. Could he have chosen something else?
Yes.
Like 9 times 4. Could he have chosen that one? Yes, he could have. Could he have chosen 12 times 3?
Yes.
Yes, he could have. And he would be just as right. If you chose something different, that's fine. It's when we get down to our bottom level that we should be the same, no matter what we chose. 6 times 6 is good. 12 times 3 would have been good. 18 times 2 would have been good. But since Ty chose 6 times 6, we're going to use Ty's. Now, is 6 prime or composite?
Composite.
Composite. If it's composite, it gets 2 branches. Okay? And what times what makes 6?
3 times 2.
3 times 2. Is this 6 prime or composite?
Composite.
Composite. If it's composite or it can be busted, it gets 2 branches. 2 times 3. Okay? Prime?
Yes.
No.
Yes.
Prime?
Yes.
Look at your list. Will anything divide out of 3 besides 3 and 1? No. Okay, so if it's prime, no branch. We're done. Prime?
Yes.
Prime?
Yes.
Prime.
Yes.
We are now down to nothing but prime numbers. Now, usually I would circle this as my answer, but I learned something yesterday with exponents to where I can clean this up a little bit. I have how many 2's?
2.
So base 2, and how many of them? 2 of them. Oh. We're going to use what we learned yesterday to clean this up mathematically, make it look cleaner. Alrighty? Now, I not only have a 2, but I also have 3's. So base 3, and how many of them?
2.
2 of them. Is there any other numbers in my bottom row? Nope. Then there is the prime factorization of 36.
Cool. That was easy.
What you got, Ty?
So what if, like, they're not 2 times 2 and 3 times 3?
I'll show you.
Okay.
We got some more examples coming. Now, I promised you 2 methods, right? Okay. Start here like this. It's called the stair method. And you put a upside down division box on it. Some people learn it this way. When you divide something out of 36 in the stair method, it must be a prime number. So what prime number will divide out of 36? 3. I like 3. Now what is 36 divided by 3? 12. Put that 12 underneath. Okay. Now, since he's still composite, I box him again. Find another prime number that will now divide out of 12. 3 again. What's 12 divided by 3?
4.
Put the 4 underneath. Box it.
2.
What will divide out of a 4? 2. What's 4 divided by 2? 2. It's now composite. Pardon me. It's now prime. No more boxes. I have 2 2s and 2 3s. Base 3, and there's 2 of them. Is that the same thing I got over here? Yes. Now, this is Coach Jordan. I like the tree method. This is too much like division and division ranch house and that stuff, and it confuses me. But some students like it, so I show it both ways. You choose which one you like. If you don't like stair method, then you just X that thing in your notes and say, don't ever look at that. We're just going to do the tree. And that will be okay with me. Cuckoo, cuckoo. Everybody all right? All right. Let's find the prime factorization of 54. Example on our book. Here we go. Let's go. 54. 54. Does it get 2 branches?
Yes.
Okay, what times what gives me 54?
Wait, what times what?
Sometimes what?
2 times.
Well, he wants to go 2 times something. That's fine with me. 20. It's got to end in a 4. 27. Very good. Could he have chosen 9 times 6? Could have. But he took the hard one, which I'm proud of him. Good job, Sam. 2 times 27. Now, what's this? Is this guy already primed? Some teachers let you stop right there. I don't like it because I found students who forget up in the tree to go looking up there in the tree. So I keep going. He's primed. He gets 1 branch and he just keeps coming down. That's me. If you want to leave him up there by himself, that's fine, but don't forget him. Don't forget him. Now, 27 will 2 branch, won't it?
Yes, sir.
What?
3.
3 times 9? Y'all agree with that?
Yes, sir.
Okay. Now let's come back over here. 2 is still prime, so he just 1 branch. What about 03?
No.
He's prime, so 1 branching. That's me. If you want to just leave, I don't like it. 9 needs 2 branches.
4 times 2.
Bull corn. That's 8 last time I checked. 3 times 3. There we go. Prime. 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 Prime.
3 cubes.
Are they all prime?
Yes, sir.
Okay, so now let's clean it up using what we learned yesterday with exponents. Base 2, and how many of them?
1.
1 of them. Ooh. Okay. What's our other base? 3. How many of them?
3.
3 of them, sometimes called cubed. Learned that yesterday. Good job, y'all. What do y'all think?
Cool.
Using yesterday to help us too, right?
Yep.
Okay, good. Sit down, girlfriend. Sit down, girlfriend. We're in the middle of learning. You got to have 2 of them or a pen or something ready to go. All right. Don't shake me around. I'm over here now, dude. You better walk over here. Stand right here. Okay, stand right there. Right there. Right there. There you may see it in a little different form, Crystal girlfriend. We may see it here in box form, where we have to fill out different things for prime factorization. Okay? Okay, if we're looking at 4 to the 6th power, what's the base?
4.
Boy, this is hard filling out this box. What's the exponent? 6. And what would be the multiplication sentence from this right here? 4 times 4 times 4 times 4 times 4 times 4. I ran out of space. I could have written smaller, huh? Boy, was that hard?
No.
So don't freak out when you see this. It's just a different way of looking at our number sentence with exponents and all that. So what's this? 12 base? 4 exponent? 12, 12, 12, and 12. And what do we put in front, in between, Lexi? Thank you, Lexi. Don't forget ever again, okay, girl? Ever again. Now that's one way we may see some stuff. Now this next one. This looks like my final solution from over there, right?
Yes, sir.
Now I want to make it long. How do I make this long? 2, 2, 2, 7, 7.
Multiplication.
And what do we put in front, in between there, Kiana? Yeah, multiplications, girl. Don't ever forget again. Okay? Now, what does this product mean?
The answer.
Work it out. So, I'm going to come over here and do it. 2, 2, 2, a 7, and a 7. Like I did yesterday with my arrows. 2 times 2? 4. Times 2? 8 times 7? Bullcorn.
56.
56 times 7. I don't know, so what do I do?
Multiply.
Multiply off to the side.
42.
42. Carry my 4. Nice try over there, Sam.
35.
35.
39.
39. So 392. Okay? Boy? Okay. What's this one?
2.
2,
2.
2,
2.
2,
3.
3, 3,
5.
and a 5. Put multiplications in between. Now let's work it over here. Let's go 2, 2, 2, 3, 3, 5. 2 times 2
4.
times 2
8.
times 3
24.
times 3.
72.
72 times 5.
10. 35. 36.
360.
Atta baby. Good job, class. 360.
You forgot to put your multiplication sign. Where? Oh.
But I have them here, though, where the answer's going to be. Don't I?
Yeah.
Okay, good.
It's good practice to put it there, though.
Good. Good practice, though. You're right. One more, just go back to our factor tree real quick. One more factor tree just to make sure we got it down. 40.
20 times 2? 5 times 8?
5 times 8. Could we have done 20 times 2?
Yes.
Could we have done 10 times 4?
Yes.
Those will all get us the same answer, y'all. Guaranteed, of course, if you do it correctly. 5 prime?
Yes.
Ooh, 1 branch. 8 prime.
No.
2 branches.
4 times 2.
4 times 2. Good. Okay, 5 prime.
Yes.
1 branch.
No.
2 branch.
2 times 2.
2 times 2. 2.
Prime.
1 branch.
2. 2 times 10. Oh, whoops, I'm sorry. 1. Add 5.
Prime.
Prime.
All right, now let's clean it up.
5. 1.
Okay, mathematically, you need to go from smallest number to biggest base number, okay? I'll accept it anyway, but when you get higher in the algebras, you got to put things in order from least to greatest. So what's the littlest base? 2, and how many is there? 3, and the next base would be 5, and there's 1 of them. What do you think? Kill it, dude.